All right, these are the notes for 12.2. In 12.2, we're doing pyramids. There is a nice link in Canvas in the Chapter 12 module that you can look at the different nets of pyramids. And in class, we discussed and compared the differences between pyramids and prisms, which is what we covered earlier in 12.1. One of the things we mentioned is the lateral faces in a pyramid are now triangles, where in the prisms they were rectangles, and that the pyramid has one base versus the two bases that a prism has. In the pyramid, we are still going to have a lateral edge. That's where the lateral faces are going to meet. And because these are now triangles, the height of the lateral face is going to be called the slant height because it's a triangle now. That is different than the height of the entire pyramid, which I'm showing here. That's actually like how tall the pyramid is. So we're only going to be dealing with regular pyramids. Every time the base is going to be a regular polygon. All the lateral edges are congruent. All the lateral faces are congruent isosceles triangles. The height of the lateral face is called the slant height, and we're using a cursive L as the symbol for slant height. We don't use S's, they look like 5s, and we're not going to use H because we already have H kind of meaning a different thing. And the altitude, which is what we call the height, meets the base at its center for every one of these pyramids. So here we have a regular square pyramid, so that's telling you ABCD is a square with edges 10 and lateral edges of 13. So first thing we're told is to find the slant height, and the slant height here is segment VM. That's the slant height here in blue. And you can use some different right triangles in this. And there is more than one way to do this. I'm going to take you through one way, but you may see some additional right triangles that you could use to help you. I'm using this triangle I have highlighted in green, and I drew it down here below. So CM is half of BC, so I know that CM is 5. VC is 13 because they told me that. And triangle VCM is a right triangle, so we can use the Pythagorean theorem, and using Pythagorean theorem we can find that the slant height, VM, is 12. In the next problem, we're told to find the height. The height is segment VO, and you can see again I outlined in green the right triangle I'm going to use here. Now, OM is the apothem of the base. Now, I know with the square it's very easy because you're saying, well, Mrs. Renfrey, it's half of 10. But when the base changes to be, for example, a hexagon or a triangle, I don't want you to think that this segment would always be half of the base edge. It's the apothem of the base. And if you don't remember what apothem is, go back to chapter 11 and look at that a little bit. So again, I'm using this. I know 12 because we did that on the previous problem. OM is the apothem. That's 5. Triangle VOM is a right triangle, so use Pythagorean theorem, and you will find the height of the prism is square root of 119. In the next part, they asked us to find the lateral area. So what I did here is kind of redraw this triangle VBC, and that's a lateral face. And I know that there are 4 in this case 4 congruent lateral faces. So what I did is I found the area of the lateral face, and I said, okay, there's 4 of those, so I took the area and I multiplied it by 4. Another way to look at that is kind of doing the same formula. 1/2 the base times the height, which is the area of one triangle, plus another one, plus another one, plus another one, because there's 4 in this particular problem. Then I said, okay, let me factor out a 1/2, the common factor of 1/2, and a common factor of 12. And what we did in class is I said, okay, now look at this and see if you can determine a general formula for the lateral area of any pyramid. And this is what we came up with. We talked about that the lateral area of a prism is perimeter of the base times the height. And we said, oh, look, there's that perimeter of the base again. We talked about why is the 1/2 here, and that wasn't in the prism. And we said, well, now that there are triangles, we kind of need that 1/2 to find the area. And we talked about that the slant height is now is a measurement we need versus the height of just the lateral edge. Our next piece is to find the volume, and the volume of a pyramid is 1/3 the area of the base times the height. So again, it's very similar to the prism, but it's only 1/3. And you can kind of see that if you kind of built a prism around this, there's a lot of empty space. Again, I put some links in the module for different ways that this can be proven. One's on a pretty simple basis, one is more advanced that some of you might enjoy. So I found the area of the base to be 10 times 10. I already knew the height back from letter B when we were doing the problem before. So it's 1/3 the area of the base times the height. Remember the height of the whole thing? So VO. And that'll be the volume. For the next one, I'm going to encourage you to push pause and give this a try. So please push pause now. All right. So to find the volume, I need to do 1/3 the area of the base times the height. So what I did here is I drew the base. It's a regular hexagon. If you remember, when we draw two radii to find the central angle, so in this case 360 divided into 6 parts, makes the central angle 60, and that makes this little angle right here 30. I know this is 3 because the base edges are 6, and I know that's split in half, so that's a 3. And by 30, 60, 90 triangles, that's a 3√3, and this is the apothem. So the area of just the base is 1/2 the apothem times the perimeter, so I know my area of the base. Then I did 1/3 the area of the base times the height of the entire pyramid, and that's where the volume came from. The next, we have a regular square pyramid, has base edges 6 and lateral edge 5. So this again is pretty similar to what we did before earlier. So again, I would like you to push pause and try these problems on your own. In this problem, I'm asking you to find the slant height, which is green, the lateral area, there's also, and the base area. So please make sure you try to do all 3 of those. So push pause now. All right, you can see here for the slant height, I again tried to use this triangle here. And so I know half of this is 3, this is 5. Using Pythagorean theorem, I can find that the slant height is 4. The lateral area, you can find the area of this triangle right here and multiply it by 4 in this case. I use the formula 1/2 perimeter of the base. So 6 times 4 is the perimeter of the base, times the slant height, which I found above, so that gives me 48 centimeters squared. And the base area of a square is 6 times 6. All right, using that same figure that you just had, I'd like you to try and find the total area, the length of the altitude, which is the height of the pyramid, excuse me, and the volume of the pyramid. Again, we did before, so you can go back if you need to. So push pause now. All right, for the total area, very similar to the prism, but remember what the other difference we talked about. This one only has one base. So I took the lateral area I figured out before, added in the base, area of the base, and I got a total area of 84 square meters. And this would be, if you were making out of paper, how many square meters of paper you need. For the length of the altitude, I'm going to just go back here a second to show you what triangle I'm using. Again, I'm dropping an altitude down here. I'm using the apothem, okay, which will be 3, and the green slant height. That's the triangle I'm using here. So I knew the apothem was 3, the slant height was 4. I used Pythagorean theorem to find that the height of the entire prism was the square root of 7. And then again, to find the volume, it's 1/3 area of the base times the height. I plugged in what I had, and that's my volume. All right, for the next one, a regular triangular pyramid has lateral edges 10 and base perimeter 12. And this one can be a little tricky. Give it a try. So the base is going to be a regular triangle, okay, and then it's going to come up. So there's actually kind of 4 triangles being involved here. So regular triangular pyramid means your base is a regular triangle, and the base perimeter is 12. So again, I would like you to try this on your own. Push pause and then come back. All right, lots going on here. For the first part, I needed to find the slant height. So to use the slant height, here's a picture of a lateral face, one of the lateral faces. And this red here, actually probably should have used a different color because I have it being 2 different things. This red and this red are different, sorry. This is a slant height, so use Pythagorean theorem. I know this side is 2 and this side is 10. Using Pythagorean theorem, I find the slant height is 4√6. For the area of the base, I knew the base was an equilateral triangle. Again, I figured out the sides were all 4 because I took 12 and divided it by 3. That's how I got 4. I know this is 2, and I know you can use Pythagorean theorem. You could also use it. This is a 30, 60, 90 triangle, and figure that out. So the base area would be 4 root 3. For the total area, I'm taking the base area and adding the lateral area. Square roots aren't similar, so I can't simplify that. The volume, I kind of got a little more complicated on the height than I wanted to. But don't forget, it's the apothem and the slant height. There are other ways to do it too. You could have done something with a radius and a lateral edge. There's a couple different ways. I decided to take the slant height, the height, and the apothem. So again, it's not half of 4. You have to figure out what that apothem is over here. And I took 1/3 area of the base times the apothem. 1/3. I think I didn't do this right. I'll have to fix that. I apologize. It'll be 1/3 area of the base. So the area of the base was 4 root 3 times the apothem. So let's fix this up real fast for you. So I'm going to have 1/3. The base area I know is 4 root 3. I think I had that before. And the apothem was this 2 root 213 over 3. I promise that when I give you that as a problem, you won't have to go and do all of that. So it won't be that complicated of an altitude. And then you'll just kind of multiply all that together. The numbers will work out a little better, but the biggest thing I want you to remember here is that you need to make sure that you're doing height, apothem, and slant height. Don't just think it's half of what it should be. So you can figure that out. Know your formulas. Talk about the differences. There's many. Again, I used right triangles. There are other right triangles in these figures that you could use to figure out all sorts of different measurements. So please don't be limited by the way I showed you. Feel free to try different ways as well. If you have questions, write them down, and I will answer them either in Canvas or in class.